What is tropospheric scattering? Tropospheric scattering. Now you see here, Earth, the atmosphere has different layer. The lowest layer is the troposphere. So it starts from 8 kilometer around and goes up to 14 kilometers. So the all different kind of activity of weather formation is happening here. So we can send the electromagnetic waves, and because of the scattering and the refraction, some of the content, some of the radio signal energy we can receive at a very farther distance. Farther means, I'll tell you the distance. So this is the scattering because of the troposphere. 12 is around the average range what we call the troposphere is, but it goes from 8, 9 to 14 kilometers. So tropospheric scatter, also called as the troposcatter, is a method of communication with microwave radio signal. Normally UHF band we use. So it starts from 200 kilometers. It can go up to 1000 kilometers. Let us take an average up to 500 kilometers. But it depends on certain things like the frequency of operation, the equipment type, the terrain, and the climate factors. All these are involved here. So the tropospheric scatter is like this. The method of propagation, it uses, as I said, the tropospheric scatter. Scatter is whenever the light meets the gas molecule or a water molecule of the order of the wavelength, so it gets scattered randomly in different direction. So some of the direction can be to the pointing antenna or receiving antenna, where radio waves, and as I said, UHF and SHF frequency are randomly scattered as they pass through the upper layers of the troposphere. So the scattering is, as I said, the particle will spread in all the directions, scattered in all the direction because of the order of the size of the particle. So the radio signals are transmitted in a narrow band, and this is aimed just above the horizon. Horizon means the height of the, say, mountain which it can cross in the direction of the receiver station. So as the signal passes through the troposphere, some of the energy is scattered back to the earth and receiver signal can pick it up. Normally, signals in the microwave frequency range, they travel in straight lines. And normally what we see, a line of sight. The line of sight of application is that you can see the transmitter. And there is no problem in this kind of communication, but the range is limited. The range is limited. You cannot go beyond a certain distance. But here, as I said, the distance can only be up to 48 to 64 kilometers. The communication distances are limited because of the visual horizon. We are not talking about when the receiver is not in our view. Here comes the troposcatter. So troposcatter allows the microwave communication beyond the horizon. That is beyond where the point you can see. So that is beyond the horizon. So these are different the line of sight, you can say receiver and transmitter. And but what about when you don't have a line of sight? So this is kind of a communication which is called as the troposcatter, because the energy which is received is very less. So receiver sensitivity is what, and other parameters play a very vital role. So this troposcatter, it was developed in 1950s mainly for the military communications in United States. It was developed, and then the militaries are also using it. Because the troposphere is very turbulent, it has high proportion of moisture, the turbulency, the eddies, the tropospheric, all the activity of the weather formation is taking place. The tropospheric scatter radio signals are refracted, and consequently only a very tiny portion, very less portion of the transmitted radio energy is collected by the receiving antenna. Both the antenna needs to be very powerful, because only very less amount of energy what we get. So frequency of transmission around 2 gigahertz, which is your UHF band, these are the best suited for tropospheric scatter system, as at this frequency the wavelength of signal interact well in the moist turbulent areas of the troposphere, improving the signal to noise ratio. So that is how The signal, in order to improve the signal to ratio, we use 2 gigahertz. This is the best gigahertz.